Hi everyone!
Hi.
Hello everyone, my name is Jasmine and I'm a third year at the Center of Aquatics.
Hi, my name is Angelina, and I'm a third year in the program too, in the Center of Aquatics too.
Hi, my name is Tamar. I'm a first year in the Center of Aquatics.
Hi, my name is Kara. I'm a first year at the Center of Aquatics.
Today we're going to be talking to you about the salt oxygen and nitrates and also pH. This is going to be so fun and fantastic. I hope you guys enjoy. But for today, I think we're going to be starting off by. Do you know Miss Jackson? Oh, wait, Miss Do you know Jackson?
We'll be starting off with pH today.
Okay, well, I guess we're gonna get started with that. So we're gonna get the materials open and get ready so you guys can watch us, and it'll be so much interesting, and you guys are gonna learn so many facts.
And if you have any questions, you can also type in the chat or unmute yourself and tell us if you have a question.
So the first thing that we need to do is protect ourselves. So the way that we do it is to put on first gloves. So we're gonna try to figure out which ones are the ones that fit us. Gloves. Oh, wait, this is a small?
Yeah.
Here. Here's large. Oh, okay.
Okay, so starting off with pH, we need 3 test tubes, of course, which here Angelina is demonstrating for us. And next we have our pH scale in our box that will determine if it's basic, neutral, or acidic.
We're going to be using 3 different types of water: ocean water, tap water, and river water.
So the first thing that we're gonna do is we're gonna fill up with the water with this, with either the tap water. So first thing that we're gonna do is fill it up with tap water. So we'll fill it up all the way up. Oops, hello. We're gonna fill it up to the 10 parts per liter. I think that's that's not part one. And then in the kit, there's the indicator, which we're gonna drop 10 drops of it, and we're gonna drop it facing down. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So after that, we cap it, and then we're gonna mix it. So the way we're gonna mix it is just doing this. Eventually, once it's all mixed up, we're gonna check in here. We're gonna see the scale, if it's basic, neutral, or acidic. So Tamara, do you want to tell us if it's basic or acidic?
Sure. Okay, so after you do that, you want to hold it up to the light, and it seems as if it's 8 to 7.5, meaning that it's more in the neutral area. it's more towards basic, but as well as neutral. So other liquids that are in this range are water and blood. That's because it carries oxygen, which makes it a little more basic.
Here you go, Justin. So on to our next test, we're going to be doing our river water. Whoa. Okay. Wait, did we do this one? No, it's not water. So the same thing, we're just going to fill it up until 10 liters. And then get the indicator and put 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now we're done with that. We're gonna mix it and cap it off. So, Jasmine, do you want to read this one? Sure. Okay. Let me just mix it up for you really well. Here you go.
Okay, so by looking at it, I'm getting like 7, which is really neutral. I'm getting 7, which is neutral, which is safe for the water.
And this is drinkable water since it's at 7, so meaning you can drink this water. And there's a river also in the Delaware River. You guys can swim there, and it's very drinkable water. So on to the next test, we're going to be doing ocean water. So, okay. Going back to the 10 millimeters, liters. And then putting the indicator again and doing 10 drops. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, no. We're going to tap it off and then start shaking it again. Tamar, do you want to do this one?
Sure.
Okay. Okay.
Okay, seeing this one, it also looks like it's at a 7 to 7.5, which is also close to the other two, which means that it is drinkable, and it's also, well, this actually isn't drinkable, it's ocean water, but that doesn't mean that it's safe for the animals that live in it.
Yay! So that really concludes to our pH test.
So looking back to our samples, it pretty much seems we have some safe water for us and for our animals, which is good. So let's move on to nitrates.
Yay!
Okay, here.
Okay.
Once again, we're using 3 tubes for our 3 samples of water. Again, our samples will be ocean water, tap water, and the river water. Okay, so first we're going to be starting with our ocean water, and this time we fill our test tube to the 5th millimeter.
So, Kira, why is nitrates important?
Nitrates are important because nitrate is a form of nitrogen, which means that plants grow or need grow because they have nitrogen in it, and they need a lot of nitrogen to grow. So when we have fertilizer has a lot of nitrogen in it, but when it rains, it goes inside the ocean, which makes algae grow. Algae starts growing a lot, and it causes overpopulation, which is called algae bloom. That's why it's important. Okay, moving on. That's nice to know, Kira. So moving on to our next step, we're gonna use our first thing. Like we have a first pill. I don't know if you guys can see it. Our first pill to determine our nitrate. So we're just gonna
put it in. And then we're gonna put our tap on it and then move it up, forwards, and back.
So, Kiara, what happens if there's so much nitrogen in the water?
If there's too much nitrogen in the water, it causes algae to overpopulate and it stacks on top of each other, which makes all the algae and anything under the algae die, which creates a lot of oxygen inside the water.
That's crazy. So what happens to the oxygen then?
When there's a lot of oxygen in the water, it causes a term called hypoxia. This means that the fish suffocate on the water, oxygen.
Wow. So, you can go.
Good to know, Kira. Thank you for that. Moving on to our third step, we have another pill. We actually put two, so this will be our second one. Once again, we just put it in and then shake it again.
Cover it. Hold it. Hold it. Start shaking it. Hold it. I got it here. So, since, what did you say again? The oxygen?
When there's a lot of oxygen inside the water, it causes hypoxia, and it's bad for anything that lives inside the water.
So low oxygen. So,
we cover the test tube because sunlight or light changes the results.
we're just gonna wait for this until
5 minutes.
later. So meanwhile, we do that. We're gonna do our dissolved oxygen. Where is it? So, dissolved oxygen.
Okay, so pretty much what dissolved oxygen is oxygen dissolved in water. Simple definition.
So, all aquatic organisms require oxygen just because they need to breathe and stuff. So some organisms require more oxygen than others. Some examples of are some trouts, which are they need 7 grams per liter. Salmons, 6 per liter. Bass is 5 grams per liter, and muskie is 4 grams per liter, and then there's pixies, there's 2 grams per liter, and then there's bacteria, there's only 1 grams per liter. So,
Okay, let's move to our first step. So of course, remove the cap. Our second step is to add 5 drops of the let's find our
So we're gonna first be testing our ocean water. So what we're gonna do. Okay. So we're just gonna fill it up all the way through. Do we have more? We got more, so we're gonna fill more in. We're gonna fill it up almost all the way to the top. Okay, cool. So once that is done, we're gonna get magnesium sulfate. We're just gonna add 8 drops. You wanna do that, Jasmine? Okay.
Hold it. 1, 2, 3, 4, 5, 6, 7, 8.
So we're gonna close it off, and then we're gonna shake it up just a little bit. And then we're gonna let it precipitate. And now we're gonna put alkaline. Oh, okay. Alkaline in it.
We're gonna add 8 drops to this one too. Oops, this one was wrong.
Now we're gonna show you guys how it looks, and then we're gonna let it settle down for a bit. Meanwhile that is happening, we're gonna get our sulfuric acid. Sulfuric. No, sulfuric. So we're gonna add it into it. So we're just gonna do 8 drops again. 1, 2, 3, 4, 5, 6, 7, 8. And Jasmine is now going to shake it up. So now the sample is yellow. So what we're gonna do now is grab this little jar and we're gonna fill it up about 20
milliliters.
Okay, cool. So we filled it up with 20 milliliters. Next thing you know, we're gonna grab a needle, we're gonna cap it, and we're gonna insert it, and then flip it over. Can you hold this?
Actually, we are not gonna do that. We're gonna do something else.
We're gonna grab the sodium. We're gonna shake it up a bit. You know, accidents happen. So we're gonna insert it in, and we're gonna flip it over. And now we're gonna move it all the way to 0. We're gonna do this slowly so we don't get any air bubbles. And there we go. What is an air bubble? Okay, so once we took out the air bubble, now what we're gonna do is insert it there now. So what we're gonna do is slowly add it into it instead of too fast. So we're gonna add like 2 drops and then like stir it. So we're gonna slowly see it turn a little bit more brighter, like a more brighter yellowish. But we're gonna slowly just add the drops in. Because if we do it too fast, then we're gonna have to do it again, and it's not fun. It's not great. But talking about the salt oxygen, there's a lot of things why we need that. Mostly because of the fishes that lives in there. And as we keep adding this on, like 2 drops each time, it's getting a little bit more brighter, as you can see. I think it's light enough for us to continue. Maybe not, a little bit more. Just 2 more drops. So,
I think you should add a little bit more.
okay, Jasmine. Oh, okay. So now it seems good now. So we're gonna remove it. We're gonna open it. We're gonna put our starch indicator solution. We're gonna only put 8 drops. So as we see now, since it was yellow, it's gonna turn a little bit more purplish because of how much oxygen I think it was in there. So what we're gonna do is put it back, cap, hold the little hole, and then shake it up. So now we see the solution, it turned like a very dark purple. For you guys, it may seem black, but it is purple on our end. So with this solution that we had gotten earlier, which was the sodium, we're gonna do it again, but much more slowly. Because we're just gonna add 2 drops, stir it. You guys are gonna see how lightly it's gonna turn. 2 drops, stir it. 2 more drops, stir it.
It's a process to change.
Stirring it again. You see it's starting to get a little bit more lighter than before. Adding 2 drops more in, as you see. You see a little bit more, it's getting there, slowly. Now we see it's getting a little bit more lighter, well for us, because it's more light. 2 drops. Look at that. Wow. You see it's getting more lighter. So we're gonna add 2 more drops. Added 1. You see, this is great. We can still see that there's a little bit of purple, but it's kind of clear. Let me see. So this kind of shows how much lighter, but it's still purplish in there. So now what we're gonna do is we're gonna check the needle and see how much from 0 it got to whatever number we got. So the number that I got was around like 6.2. For how much oxygen was in here. So the fish that will live here would definitely be a salmon, because they can definitely live in those type of oxygens in there. So anything else is oh,
Next, we'll be checking up on our nitrate.
Kara, you want to do that? Girls. Go. So, oh, no.
So here, I think I'm getting a 4.
Looks like a 4 for me, so we're going to look at it here.
Yeah, it looks like a 4 to me.
Or 3.
So R4 pretty much just goes on to
How much nitrogen? How much nitrogen is in the water?
Kira, do you know how many nitrates is in the water?
4. 4.0, which is probably good. Yes. Yep.
So which high nitrates are caused by agricultural runoff from the
Fertilizers. So a lot of people who like to grow a lot of plants around their houses, it's good. It looks great on your house, but it's also bad for the environment because all that fertilizer is all those fertilizers that you're putting in your plants, it's good for them, but sometimes once it rains, all that water is going to hit that fertilizer and then it's going to run off to the ocean or sometimes to lakes and ponds or different areas that have water. So sometimes algae loves nitrates. So like Kira said, algae loves nitrates so much that they will eat all of it. Eventually, once they eat all of it, it dies. It dies off because there's no more nitrogen to eat and they ate all of it. So once it dies, bacteria comes in. And all that bacteria comes in, it takes up all the oxygen, and that's where we get the soft oxygen. Kind of. So where all the oxygen is going, it's a lot of nitrates, the oxygen goes low, bacteria comes in, the bacteria eats the algae, and everything under it dies off because they're not getting food, sunlight, and other things. So everything there is a dead zone. It's not good. It's not good for the environment. It's not good for other animals, neither for us because we can't drink that water. So therefore, it's good to get nitrogen in your plants, but it's also not good for algae. Well, for anything. So, yeah. So, Jasmine, why is water quality testing is important?
So it's very much important so we can detect how much oxygen is in the water. So
like things can live there also.
Like our animals, like here we detected that salmons could live in there, which they'll be perfectly fine. And for us to drink it too as well. And to shower, what we do on a regular basis, wash dishes, clean, swim, drink water, of course.
So, like, water from the river, we can drink that, we can use that for our daily stuff. Tap water, we can somewhat kind of do it.
We could also kind of drink it, but not really, but it's good use still for us on a regular basis as well.
Ocean water, it has a lot of salt, so it's not really good for us to drink or shower or do anything because we will perish.
But it is good for some of our animals who are into salt water.
Like some of our marines, like sharks, fishes, dolphins, horseshoe crabs, and basically, yeah.
All of them are impacted by water quality.
Do you guys have any questions for us? So we do have a question, which is just tuning in. With the kit you are using, what is the range for high nitrates and low nitrates?
So right here, I can show you guys. With the kit, it kind of shows us. So with here, on the top is 0.0, and at the bottom it is 15.0. So that is how much far the 0 can go to like 15. So that's how much nitrogen and nitrates can be in the water. Anything else? Like any more questions you guys have?
Okay, so thank you guys for joining us. We appreciate it and hope that you enjoyed our little water quality testing. And I hope you took away something from this and able to now do also quality testing of water and determine if your water is safe or not. But thank you for joining us. See you guys soon.
Bye.